Hello everyone, and welcome to OneClass. My name is Jeff Krause. I have a PhD in physical chemistry, and today I'm going to run through a few undergraduate, high school level physics questions. So here's our first one. So starting with the formula for the moment of inertia of a rod rotated about an axis through one end perpendicular to its length. So that would be something like this, where this is the axis and that's the rod of length L. Then the moment of inertia is given as ml squared over 3. It wants us to prove that the moment of inertia about an axis perpendicular to its length but through its center. So here's a rod, and now there's the axis. Right now this is at L over 2. Or at the center of mass of the rod. And it wants us to prove that it's ml squared over 12. So the easiest way to do this is to use the fact that the moment of inertia about any axis perpendicular to one about its center of mass can just be found by adding md squared, where d is the distance that we're adding, or the distance that we're translating the axis. So in this case we're looking for the center of mass and we have a different one. So we'd want to rearrange this. So our I about the center of mass should just be I, our given I minus md squared. And then in this case our d is just L over 2. So plugging in the values that were given. So this would be ml squared over 3 minus m L over 2 squared, which is ml squared over 3 minus ml squared over 4. And now giving them similar denominators. So 4 ml squared over 12 minus 3 ml squared over 12. And so then that equals ml squared over 12. And so our i's about our center of mass is just ml squared over 12, which is what we were asked to prove, so presumably that's the right answer. Okay, so the moment of inertia about one end, so we can use this equation. It needs to be rearranged, so that looks good. We've moved by this L over 2, so that looks good. And okay, so all that looks good to me. So the solution is correct. Okay.